Greetings, my fellow football enjoyers, or soccer, depending on the country. I'm Kathathorn Ruenpirom, currently a Mathium 4/3 student. I'm number 3, and today I'm going to show you how to solve this problem as a work assignment for my mathematics class. So, let us get started. Now, it said here, a shareholder sold some shares of stock worth $5,000. So that means that some shares of stock, we didn't know the value of it yet. So that means that I could say, let's imagine this imaginary number of shares is equal to X. Okay, now let's go on with it. Several days later, the stock having dropped in price by $10 per share. We still didn't know what this does, but we still know that, okay, so the stock having dropped in price by $10. That's good to know. And now, he actually repurchased. That's right, he repurchased for the same amount of money, but 25 more shares than he sold. That means that when he sold the stock for $5,000, he also repurchased it back in $5,000. But now the number of shares actually increased from this imaginary number to imaginary number plus 25. So that means that there's actually X plus 25 shares now. So the question asked, how many shares did he sell? Well, let's go to here, the solution. There's actually a hint given for us. So it said here that the price per share sold minus the price of a buyback share is actually equal to $10. $10 is here. So that means that the solution is implying that the imaginary number, right, the imaginary price, right, price or number of stocks minus the price of buyback share will be equal to $10 because the stock dropped in price by $10. So, since it is like this, we can actually transform it into a formula which is this. So, sale proceed over number of selling shares minus investment over number of buying shares equals to 10. So that means basically what sale proceed and investment is just the price. The price overall, the price at first. So it's $5,000. And the number of selling shares, which is the number of shares he sold at first, which now we named it X. So it's X. And then the number of buying shares, which is basically the number of shares he bought back, which we know is X plus 25. So we can now write it down as, so 5, and this is too thin, 5,000, so 5,000 over X, right, because it's the number of the selling shares, minus also 5,000, the price stays the same, right, the price stays the same, he invested the same, he sold it for the same price, over the number of buying shares, which is X plus 25, and now it equals to 10. Okay, now what to do with this? Well, what I would like to do when I came across these types of questions is that I would like to actually cut these two off. I don't like them being divided. I don't like seeing them being divided. So I'm going to do whatever I can to make them not divided anymore. So what I would do is I would multiply the whole equation by X times X plus 25. Now, why would I do that? Well, the reason I would do that is, let's say that I actually did it. 5,000 over X, and then times X plus 25, and also for the same thing, duplicate it. Here we go. Minus plus 25. There. Now, we can actually see that when I'm going to actually write it in full actually. Okay, so when I actually write it, now I could actually cut it. So x plus 25, I could cut that, and now it's linear. Now there's no value dividing. The same is with this. So let's say I cut x, I also cut x here, and now there's no value to divide. There's only value to multiply, which is what I want. So I'm going to proceed with this. So x, and then x plus 25, x plus 25. I'm going to actually add 10 here. Okay. So that means that now the equation will be changed to something like this. 5,000 times x plus 25 minus 5,000 times x equals to 10 times x plus 25. Okay, since we now got this value, what we could do with it? You see the number 10 here. We could actually cut it even further, since both sides, right? Both sides actually have a value that's multiplying and also have a 0 in the digit. So we can actually cut it like this here. So 10 has 1 0, so we cut it. And then this guy also has 1 0, we also have 1 0. So if we cut 0 from all of them, the new value that we would get is 500 times x plus 25 minus 500 times x equals to x plus x times x plus 25. You can see here that we cannot cut any further. So what we would do is that we would multiply them inside the brackets, each of them inside the brackets. So now it's going to be 500x plus 12,500, I think. No, sorry. What is the value again? Okay, 500 times 25. Yeah, 500 times 25. Yep. Okay, 12,500 minus 500x equals to x to the power of 2 plus 25x. As you can see here. Now, since we got this, we can actually see that 500x and minus 500x is on the equation. We can actually cut them both, since it accumulates to 500x minus 500x anyway, so it equals to 0, so we could also cut them both. Cut. And now we are left with this. X to the power of 2 plus 25x and also 12,500. So what we would do is that we would transfer this onto this side, so it would actually equal to x to the power of 2 plus 25x minus 12,500. But when we do these kinds of equations, we don't actually want them to be on the right side. It doesn't really look very nice. So I'm just going to swap places from this guy right here over to this side. So that means that the value on this side is still the same, but we only switched sides. So it's x to the power of 2 plus 25x minus 12,500 and equals, since there's no value here, it's going to be 0. There, done. Now, when we are on this step, you could actually factor them out, right? You can see the pattern here. Here, there's going to be two brackets with x on each of them. You know, you're going to try and find the correct value, but it's going to be pretty hard since it's a pretty large number. So, what I'm going to do is I'm going to show you a trick that can help you solve this much easier and quicker too. So, see the middle guy here, right? You see the middle guy here? Right. So, what you would do with him is that you would use the power of difference. So, I'm going to actually transform it into a form of difference. What does that mean? It basically means that I'm going to transform this into 125x minus 100x. Why? Because when these two well, when we both find the difference between them, the value actually equals to 25x. So the value is still the same, but we just changed how it shows on the equation, which allows us to actually solve this equation. So I'm going to write it down, x plus 2, right? X to the power of 2 plus 125x minus 100x minus 12,500 equals to 0. There. Now, what we would do next is that I would try to pull some value out. So, we would look them as this is a blob, this is another blob. I'm going to wait. This was one blob, this is another blob. These two blobs, we are going to pull some value out of it so that we factor them out, basically. So it's now able to factor out. So, what are we going to do is, since x is now to the power of 2, and also there's 125x, that means when we can actually pull x out. So it's going to equal to x times x plus 125. Now, let's go to here. So, 100, right, 100 can actually be pulled out from these two values, since this guy's value is actually pretty big. So there's actually two zeros here, so you can actually cut them off. So I would pull 100 out, which means that pull 100 out, so minus 100, and so now it's going to be times x plus, oh, would you look at that, 125. When I time it back in, it's going to be minus 100x, and when I time this back in, it's going to be minus 12,500. So it's the correct value, equals to 0. So we are now factoring them out. So that means that there's basically two values for us. So x plus 125 and x minus 100. Both of them equal to 0. So what we would do is that we would just solve it normally. So x minus 100 equals to 0. So the value we get from x is going to be 100. Now we're going to solve the other guy, which is x plus 125 equals to 0. So x is going to be equal to 100. 1 minus 125. Sorry. So now we have these two values, which both of them could actually be an answer for this question. What would we do to find which is the right one? Well, think of this logically. Can the number of shares be negative? The answer is no. Of course not. The number of shares can't be negative. It can't ever be negative. You can't have negative shares. You can't sell negative shares. So that means that this value is actually invalid. You can't use it. So the only value you could actually use is this guy, which is 100, right here. So that means 3 dots, the number of shares sold at first is equal to 100. And that is the answer for our question. So, thank you very much for watching. Hope you enjoyed it, and I'll see you next time.